All right, the next piece we're looking at is graphing equations in intercept form. So graphing these in intercept form, basically we're going to find all the information that we found last time. We're going to plot our intercepts. Then we're going to find and plot the vertex. Okay, and then we're going to use our modified table of values to graph this thing, and we're going to mirror our points over the axis of symmetry. Okay, so let's take a look at this. So first thing that I need with this guy is my x-intercepts. So my two x-intercepts are going to be at the points -3, 0 and +1, 0. Remember, it's backwards of what it looks like. So I'm going to come right down here. I'm going to plot those 2 points. Here's -3, 0, and here's +1, 0. All right, now I need to figure out what my vertex is. So to find the vertex, you got 2 different options, right? We can use our little formula. So to find my vertex, right, I can do, okay, -3 + 1 divided by 2 for my x coordinate. -3 + 1 is -2. -2 divided by 2 is -1, right? So that's one way that you can do it. The other way that you can do it is you can actually just look at your graph and like count your fingers in until you find the middle. So the middle is here at -1. That's going to be my axis of symmetry. Because remember that axis of symmetry always goes through the vertex, right? So it's going to have to go through where my vertex goes. And then all I have to do is figure out where in this axis of symmetry does my vertex actually go. So I'm going to take this -1 and plug it back into the original equation. So y equals -1 + 3 times -1 - 1. -1 + 3 is 2. -1 - 1 is -2. And that multiplies to -4. So my vertex is the point -1, -4. So on my axis of symmetry, I'm going to come down here, put a point at -4. All right, and then the last thing we're going to do is we're going to do that modified table of values thing, right? Remember we looked at that one table and we always use the same table? So that's what I'm going to do. I'm going to recreate that over here. And I'm just going to go with the positive numbers, right? Well, 0 on the positive numbers. So 0, 1, 2, 3. If those are my x's, then my x squareds are going to be 0, 1, 4, and then 9, because remember 3 squared means 3 times 3. And those are the points I'm going to plot from my vertex down here. So my vertex, that counts as 0, 0. So 1, 1 for my vertex, I'd go over 1 and up 1. There's my point. 2, 4 for my vertex, I'd go over 2 and up 4. And hey, look, that's the intercept I already plotted. I already knew there was going to be a point there, right? So that's a verification. I know that I did it right. And then last one, I can go over 3 and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I can just mirror those points over, right? This is 1 space over, so I'm going to go 1 space over. This is 1, 2, 3 spaces, so 1, 2, 3 spaces. And there's the graph of my parabola. Ta-da! All right, so it's not super hard. Let's take a look at our next one. So this guy, we're going to start the same way. I'm going to find my x-intercepts, right? And they're going to be backwards of what they look like. So -4, 0 and -6, 0. And then I'm going to come down here and plot those. Here's -4, 0. There's -6, 0. Cool. So next step is I need to find my vertex, right? And again, 2 ways you can do that. You can just count in between these and say, oh, look, my axis of symmetry is at -5. It's right in the middle. Or you can come back up here and use that formula. So to find the x coordinate, it would be -4 plus -6 divided by 2, which is -10 divided by 2, which is -5. It gets you the same number that we found here. So you can do it either way. All right, and then I'm going to plug the -5 back into this equation. So my y is going to be the opposite of -5 plus 4 times -5 plus 6. -5 plus 4 is -1. -5 plus 6 is +1. And there's that negative chilling out in the front. When I multiply all that together, that's going to end up +1. So my vertex is the point -5, +1. It is here. All right, and that looks right because this is this is making a parabola that's upside down, right? And that makes sense because our a value was negative. So we knew all along that this thing was going to be an upside down parabola, and that's what I'm seeing happen here. Okay, so last thing I'm going to do is I'm going to plot those last couple of extra points using the same modified table of values, right? This is my 0, 0. The only thing I have to do differently with this guy is because it's an upside down parabola, when I go over, what I'm going to do is I'm basically going to switch my up and down directions. So instead of going up, I'm going to go down instead. So normally I'd go over one and go up one. Well, I'm going to go over one and go down one. And that makes sense because I have a point there, right? Next one, normally I'd go over 2 and up 4, but this time I'm going to go over 2 and go down 4, right? And then normally I'd go over 3 and up 9. I'm going to go over 3 and down 9, which is not quite going to fit. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to be down here somewhere, right? And then when I mirror those points over, again, they don't quite fit, but it's going to look something like that. And there's my parabola. Make sure you put arrows at the ends of your graph when you draw those so it looks right. Okay, and that is how you graph a quadratic equation, a parabola, that's in vertex form, intercept form, sorry. Find the intercepts, find your vertex, and then use that same modified table of values that we looked at last time.